welcome back. Last time we worked on the compare utility and we saw how to deal with files, how to open them, read them, close them. Files are really useful. We use them in all sorts of different applications. This time we'll look at the ls command. It can give you the information about the file size, owner, and lots of different things. Very useful and commonly used utility. So if I say ls-a, it gives me the list of files there. Let's create a file. I'm gonna say f.txt. When I do a ls-l, it shows me information about the current files and directories inside this ls directory, which I've created here. So it shows you the permission on the file. The way to read this permission is the last 9 characters of this field tells you about the permissions that people have. For example, rw a hyphen means you have a permission to read and write and not execute it, as in cannot use f.txt as an application. For example, the executable Python has an executable permission set because you can invoke that as an application or a command line tool. The next set of characters tells you about the group permission. So anyone in your group can read this file but cannot write to it and cannot execute it. The last set of permission tells you the permission that anyone else that is not inside your user group and the user, so they can only read this file and not do anything else on it, which is very important. The first character is a hyphen, which means this is a regular file. For example, if I create a directory, let's say tmp, and I do a hyphen l again, this will be a d over here, which implies that tmp is a directory. As you can see, the executable bit is set here for user, others, and group, which implies that you can access the directory, you can go inside, list the files, or do something with them. So f.txt has a file size 0, and this directory has a size 4096, which is the size that it takes up inside the system. Okay, so that's the basics of ls command. So now we'll drop into the Python shell and look at how to access the directory structure. The most important module that you'll be using while accessing the file system is the OS module. I do an import OS, and let's try listing all the files inside the directory. So I'll say scandir. If I say os.scandir and dot, it gives me an object back which contains the information about all the files inside this directory. Dot means the current directory, and dot dot means the parent directory of the current directory. So os.scandir dot means you want to display the contents of the current directory. How do you even know what the current directory is? If you say os.getcwd, it gives you the path to the current directory. So os.scandir returns an object which you can actually convert to a list, or you can print the contents of it. So if I do a list os.scandir, this says go over all the values in the object written by os.scandir and convert that to a list. And for now, we don't really have to go into what kind of object os.scandir returns. So we get 2 different entries, which is right. We got f.txt, which is one of the files, and tmp, which is the directory. So what can we do with that? Let's try and save this list inside a variable so that we can play with this. x0 gives me a directory entry f.txt, and os.scandir doesn't have a order on the way it presents the results to you, so you cannot expect that the directory entries that you will return will be in a specific order, ascending, descending, or something. So be careful with it. Your code should not expect any sort of ordering on the return value. Now let's see what kind of properties does this directory entry have. So yeah, I do a dir on x0, and as you can see, it has a bunch of things. An inode, is directory, is file, is symlink, name, path, and stat. For example, if I say .path, it gives you the relative path of that file. So ./f.txt, that means inside the current directory is f.txt. Now let's say name. So you get the name. Is this a file? True. Is this a directory? That's false, because f.txt is a file. However, I say x1.sdir, that will be true, and if I do is file, that'll be false, because tmp is a directory and not a file. So you can use these 2 functions to figure out if you're dealing with a directory or a file. Let's look at what stat gives you. So that's a function, and if I call that function, it gives you more information about the file. So it tells you the mode would be the permission bits set on the directory of the file. There are 3 different numbers associated with each file or directory. The first number tells you the permissions regarding to the user, and the second number tells you permission regarding the group, and the third about permission that's granted to anyone else that's not a part of your user group. And there are other information, for example, user ID, group ID. We don't really have to go in detail with other fields for now, but when we write this ls utility, we'll see some of the fields and then use that information. Okay, so we have looked at almost all the functions and attributes available to a directory entry object. If you're familiar with the Unix command line, you know that there are commands like mkdir, rmdir, which you can use to create or remove files or directories. Let's start by creating a directory. To create a directory, you will say mkdir and the name of the directory. I'm going to say pdir. If you look on the left hand side in my Visual Studio window, you'll see there was a new directory created, which we can verify by doing another scanner. And if you do not provide any arguments to scanner function, it scans the current directory. And you can see there was a new entry added. How can you verify that that was a directory and not a file? Go ahead and try that. What if we want to change a current directory from ls to, let's say, pdir? I'll say chdir and pdir, and there we go. If I do a get cwd after that, you can see that we are now inside the pdir directory inside the ls directory. So pretty easy. If you know the Unix command line well enough, it's almost the same as translating those command names to these function calls. And I suggest you to look at the functions available inside the OS module, and I've provided a link in the description box. Now let's go back to the parent directory. So I do a os chdir ... and we get back to our parent directory. Now let's say I want to find out the size of the file f.txt. To do that, I can just call the stat function on f.txt. And if you remember, we have also looked at the stat function earlier, and it had a field called ht_size. So you can use any of those. And if you have a directory entry already, it's much easier and faster to simply call the .stat function on that, because it caches the size of the file. But if you do not have a directory entry, for example, you haven't done a scanner on the directory, or you do not have a handle on it, you can call os.stat with the name of the path of the file or the directory, and it will give you that information. You can see the size of our f.txt file is 0 bytes because we do not have anything inside of it. Now let's try and write something inside the file. So I'll start by saying f equals open and f.txt, like we do to open up a file, and then we write a string. This is a file, let's say. Okay, so we have to open the file in the write mode, and I say that, and then say f.close, and then do a stat on f.txt again. You can see the size of our file is now 14 bytes, and if you compare that to the 14 written by f.write, they are the same. So f.write returns the number of bytes it successfully wrote to a file. Because our file was empty, those are the only 14 bytes. So that's a simple check that our f.write went through by writing all the contents of the, and not just return a random value. Now this file is actually stored on the disk with 14 bytes. So now let's think about how we will go about writing a function that can list the files and directories inside of directory, for example. So I'm gonna start by just opening up new terminal. What I'm going to do is just do a simple ls. If you just say ls, it prints the name of the files and directories inside a directory. If you think about it, it's like pretty easy, right? We can do a os.scanner in the current directory wherever the user executed the script, and we can print the name of the files. os.scander gives you directory entry, and if you, for each entry, you print the name attribute, you'll basically have this functionality. Now let's look at a more involved functionality. ls-l gives you more information about the file and directories, and we looked at the output. Now let's go over all the different fields. So the first is easy. That's the permission bit, that's the type of the file or whether it's a directory, and that's the permission for the user, then the group, and everyone else. And one tells you how many links to this file. So f.txt just has one link, so that's just the file itself. And pdir has two, that means there are two different things inside pdir directory, and similarly tmp has two different things inside tmp. And now you might be wondering that tmp and pdir are empty, so how can they have two files or directories inside them? And the answer is that every directory has a dot and a dot entry inside of it. So dot is the current directory and dot is a parent directory. So that's why a directory always has two things inside of it. The third field is the username, who owns that file, and the fourth is the group name of the username, who owns that file. And then there's the size. This is the date it was last created, and this is the date of the last time it was modified, and then the name of the directory. And all of this information you can actually get by using the stat results. So we can get the size and from the directory entries. This should be easy again. So those two are like very important functions, and if we can even get our program to that state where you can print the contents of a directory and print most of the information of the directory, will be pretty good. Next time we'll start by writing a function which can print all the contents of a directory, and also given a switch can print more information about those files or directories that we just learned. And for now, just play with some of the functions and maybe just try writing that function yourself. So I'll see you next time.